Welcome to a new test and teardown video. Look at this monster. It is quite big. Well, I think it's about the same size as a lot of other stuff that I've been playing with lately. It's 31 kilos. It is from a company called Kustom Instruments in Kansas. And this is some Avionics actually. Base station test equipment for transponders for planes. So this thing can do all the different modulations, tones, data, and whatnot. All the different pulses to initiate transmissions from the transponder. We got all the different data rates, deviations, integration rate, echo, blah 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 blah, whatnot, DME, all the we got some different modes. DME, I think that's taken, isn't that the military mode, right? But anyway, we got all sorts of funny modes. I have absolutely no clue whatsoever how to use this thing. We got a million different things. It's gonna be fun. If there's anything to see here, there's an attenuator, a really nice variable attenuator. So if this blows up, at least this is the thing to score. The RF output, I think this one will be 1030, 90 or something in this area megahertz. And the pulses, they will be in this microseconds, really short pulses. So I am a little bit curious if I'm able to detect this. There's a frequency monitor here and some stuff. So maybe I will be able to detect something here. When I picked this up a few days ago, we booted up another one exactly like this, and it kind of blew up, and smoke and bad smell came out of it. And we also powered this up for a few seconds, and we saw no smoke from this one. So if there is a big chance this video is gonna be a lot of fun. Oh my goodness, this is the rear side of this unit, and we'll be able to see the name plate. The good old HP power plug. Maybe there is another more fancy name for this, but I kind of called it the HP because all the old HP equipment I play with, they got this connector. It seems like all the seals are intact, so this means nobody was in here. That is a very good sign when you play with old vintage gear. This one is from 1978, so it's more than 40 years old already. I am a little bit worried about all those connectors. So maybe it's for other test equipment, other kind of stuff that is important. Maybe this unit can't do a lot of stuff without this, and I don't have any more. So let's see what this can do alone. Otherwise, we're just going to see what is inside. So I'm ready to power this up. It's really a big unit. Maybe I should try and push it in a little bit deeper because I'm sitting here really weird. I connected the RF output. Let's get some light to the spectrum analyzer. Got 1 gigahertz in the center. Oh, that is a funny power switch. Let's just turn it on and see what happens. Yo, look at that. We got some squiggity pulses. So yeah, it is definitely transmitting some sweeps. It is 190 watts. Holy moly, that is a lot. And now it stopped. No, it is again. So I think this is the display that will show us all sorts of megahertz. This is the frequency thingy, right? now the... I don't know what... Okay, so there's definitely some... Ooh. What is this doing? So I got some -0 megahertz. Maybe I'm doing some... What am I doing wrong? On cal. I don't know what that is. I don't know what anything else is here really. I am just totally out of my comfort zone. I got no idea if this is bananas or apples I kind of dial in here. Acceleration, ooh, let's do that. Let's... Anyway, of course I'm gonna read the manual, and of course I'm gonna go and figure out what happens. It's actually a lot of fun just to power something on, see what you're able to figure out, and see if you can get... Oh, those are really tough. But yeah, I get some squiggity pulses, and it's somehow a really wide sweep. I didn't expect that to happen. So I think there's an oscillator that is not in lock. It is definitely not what I expect. Why would it do that? It was supposed to send on a special frequency, right? Really weird. Okay, I've been playing a lot with this thing now, and I think there's definitely a lot of stuff broken. I do get some pulses out of this one. It's not that cool, 600 kilohertz. Some pulses, and no matter what I dial around here with, I'm not able to see any differences no matter what I do. The display here seems to be a little bit kaput. Whatever it seems to be able to read, it's just not doing anything at all. Sometimes I measure some funny numbers and then it kind of goes away and yeah, measure distance, power, what kind of test distance. See, it's also very sensitive to... I don't know what is wrong with this thing. Of course, I also don't know anything about how to use it. And the RF output is definitely generating output. And let's take the marker here. And then, so this sweep here is... What is it, 600 megahertz? So yes, the top here is 1.2 gigahertz, and it's quite flat. So there's definitely a really nice controllable oscillator in there of some sort. And then the stop is 839. So that is what it can do. And of course the attenuator works. La 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 la. We can let's go to the trace here and just clear this right. So you see those pulses, and it's going. It's a lot more active in this area, in the 800 megahertz. See if I dial down the attenuator. Ta 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 ta. And that works. So there's at least one cool component we can use. So far so good. And I also really like the buttons. Those shiny aluminium buttons, they are super sexy for all sorts of homebrew thing. They are really, really nice with the double buttons here. They're beautiful. And look at those. Wow, with bulbs in them and all that is really nice. Is this really original? One button here is black like this, and the other one is this shiny. Why aren't they exactly the same? Anyway, yeah, this thing definitely doesn't do anything cool, nothing I can use for anything. And anyway, I promised a teardown video, so we're going to figure out how to open this thing. We got some screws here. It's probably, I need to call for some of my kids to help me lifting this thing up. Just to get it up on the table here is also a two-man problem. we are inside, as they say. Wow, look at that. It is just amazing. It's really well built. So we got 11 PCBs in sockets we can have a look at. It's full of, what is that, TTL? I'm a little bit worried about all those tantalum capacitors. Oh, we got some crystals down here. What exactly is this? Is this transformator maybe? With all the different outputs? So that will be in a case of its own. We got some more PCBs here and tons of wires. And what exactly is this? Oi, oi, oi. Somebody cut a lot of wires and put in some sockets or some ICs and stuff here. This is some nasty modification. I really would like to look a little bit more on that. Yeah, okay, this is the front panel indicators in 2 rows to show exactly what we're reading and what is going on. We got the 5 LED 7 segments hand soldered with all the wires. They're nice in sockets, and all those wires goes to all the 7 segment decoders and counters like that, and then into a big fat cable harness. Holy moly. We got some RF components down there. We got this super nice rotary attenuator. That one is interesting. What is that? A power coupler or something? We got some more RF components down there. There's actually a layer more I want to have a look at. There's also some funny stuff going on there. There's a lot of stuff to look at. Feed through capacitors and filters. Yeah, let's have a look at the other side. That will probably be all the power supplies, right? With some op amps or all the parts for the power supplies. This is how they made all the power supplies with the ICs up in the power supply. That is really nice. Oh, have you seen those transistors down there? Aren't they funny? They look like a little bit like TO3, but they got 3 nice. So, oh, maybe this is a socket. Is there something on the? No, there's not. There's nothing on the outside. That is some of the really fun. I can't remember I have seen this type of transistor before. So that is interesting. Okay, I need to shine some more light in here so we can have a look at it. That will be a lot of counters, pulse trains and stuff. Because look at all the diodes that goes through all the logic down here. That will be coding of pulses, delays, and funny pulses. And this is, of course, oh man, this Teflon wire here is absolutely nice. And we got some more input semi-rigid coax and some more funny boxes down here. Some more secret boxes. We need to disassemble this a lot more to see all the cool things. This PCB here on the right top side got me a little bit curious. What is this black thing? Allen Avionics. Got an input and output and just a ground. That's all. So it's a delay line or a filter or something, but it's really nice. That is quite interesting. So this is the bottom of the unit. It is, of course, where they are hiding all the fancy RF components. I think we need to open all the funny boxes and see what they can do. But first of all, I see a little attenuator. And then we go into the semi-rigid, and then we can see where the signal is coming from. And this super nice RF attenuator. All those really neatly placed units. We don't know exactly what they do. Ooh. But they're definitely worth a look. See, this is the frequency. So this is in here, right? So this is where all the magic is created, I guess. We've got some really nice... What are we doing here? This is looking spooky. Oh, okay, those are tantalum capacitors. Ooh. I don't like them that much. And we got a crystal. I haven't seen a CPU or anything in here yet. Maybe there's not really a big brain in this thing, other than just counters and timers and flip-flops and gates and stuff. But I'm going to have a look at all the PCBs on the other side as well. Here is one of my secret tricks on avoiding looking like a complete idiot when I want to assemble stuff again that I look into. See, I add some little secret numbers on everything like this. So I got both alignment, so I can rotate everything correctly, and also so I know exactly where everything was. So it's a really, really smart trick, and this will save you a lot of headaches when you pull things apart. So this is the bottom with all the lids taken off. Let's go on a little walk through. So this is the frequency dial. This is geared, so I guess there will be some sort of a resonator in here or a variable capacitor. I think what we see here is only the controls of the oscillator, but because I think the oscillator is under here somewhere, because I don't see anything here capable of handling gigahertz signals. So this will only be pulsing or modulation or something like that. And we don't see any outputs here either, right? And then I don't know yet what that is. It could be a simple RF switch, because I think we got output from two different systems, because there is an uplink or downlink frequency, 1030 and 1090 megahertz, and of course it is able to simulate both the uplink and the downlink frequencies, and that is why we have two different synthesizers and generators. I actually think this will be half of the synthesizer, of the two synthesizers, and then we have the signals coming from here and from here going back here. So here's the crystal and here's the crystal, and they're identical, those two circuits. So this is of course another injection and PLL and output. So that is why we have those two things, and all the stuff that we see here in the middle could also be dividers and counters and stuff for the two different systems. I really don't know, because we don't have the schematics. We only got a user manual that will tell us how to use it. Another crystal and a lot of counters and timing logic. And here we see like 3-4 different signal stuff. And again, see this funny product, input and output, and now it says something with 500 ohms. So maybe this is a delay line or a impedance transformation something. I don't really know what that is yet. but now we have seen 2 of them. And also we got the 2 signals like this. This also looks a little bit like, see, diode switching. Maybe this is the pulse generation or modulate data input something. Could be. We got 2 crystals again here. Got a lot of really interesting boxes here. I can't wait to play a lot more with this. Linear RF detector. Of course we need to know what kind of RF levels we're generating. So this one also goes through here. I think I'm gonna go and swap this back and forward a few times and see if I can figure out the signal path, because it's just easy just to follow the output, right? And where's this coming from? Okay, this is the detector. It goes in here. Okay, this thing can detect the level and the whatnot, right? So it's gonna be a lot of fun. So this is the signal, or this is the cable from the output attenuator. Yeah, the front connector, right? And then there was an attenuator. So it goes into this directional coupler. And this is the coupled signal. What you see here is actually the label in and the label out. It is actually because they are using this the wrong way. Because of course normally they put signal this way out. And that is because this directional coupler is not used to measure the output power, but it's used to measure input. If somebody puts signal into the RF output, it will go straight through the coupler this way. And then it's gonna go into this detector. So there's a detector here that sends out the signal to this system here that will probably turn something off or set an alarm or whatnot, right? So this is exactly what they're doing there. So this is the output signal that goes to the attenuator. The output of the attenuator is here. Is up here. And it goes to the directional coupler. And then out we go. So far, so good. So where's this one coming from? So there's another module down here, and I think it is this big baby. Oh, we can't even see that one. Oh, so there's and this is the other half of the frequency oscillator thing. Definitely need to look in that one. And then there's another interesting box here. But it also looks like this entire digital system here. You can just unplug or unscrew this screw, and then it's supposed to flippity floppity, or just maybe just unscrew it somehow. I don't know how to access this screw, but yeah, okay, that is something I could do. But before I play more with all this disassembly, I want to measure some voltages and see if everything is okay when it comes to the different voltages, because I see here some test points, or those will be the different voltages. So those I'm gonna measure, and this is the 5 volts and so on and so on. So this is the first step. So now I pulled up the entire digital module with everything, so now we can much easier see the entire RF path. I've added a little bit of info here so it's easier. So this is definitely the output I already explained about. This is the reverse input detector, and to prove my point is, let me see, linear RF detector. Right, so this one will detect what is coming back. I think it's actually also capable of measuring what is coming the other way, but in a very, very weak coupling. So it could also be that this is what they're doing. What else can I say? I think this is maybe a gate. See, there's probably a low frequency here, or injection of some sort, or maybe just an on-off gate in here for the pulses. And again, we got a directional coupler. And this could also just be for the 2 different frequencies that you can get out. So here's a low pass filter. They typically, this is probably a step impedance filter. They most likely look like this. And then we got those signals coming down here. Also, I opened the other side of the frequency adjustment. And what you see here is not gigahertz frequencies, right? This is what, 50 megahertz, 100 megahertz, 200 megahertz maximum. So this is a very low frequency oscillator. And of course, this is mixed together with something else to set the frequency sweep. Or it's actually a delta sweep. See, it says delta frequency. So that is not this, not the entire frequency, or this is just a sweeper. So this is probably mixed together with the output. And what is that thing? I think this is just a filter because there's nothing else connected to it. Only input and output, so that's most likely a filter. And this is probably the main output. Comes from this unit. I took off most of the screws from the other side. And then this is the output, and then it comes back here. So we need to go back and forward a few times and to understand more of what is going on here. So I guessed right by looking at this oscillator circuit. It is actually, I turned the variable capacitor all the way in, and it is 3.7 megahertz. So how about we try and dial this capacitor all the way out? How much is all the way out? I think it's, yeah, this is all the way out. So that is 4.1 megahertz. So this is the range of this oscillator. Alright, so it's multiplied 1,000,000 times and mixed in with this and that. Let's look a little bit on all the different plug-in modules. See, this is number 1, and this is a classic 4-layer board actually. And look at the layout. This is done manually. All the tracks are really nice. I'm a little bit unsure about what is the idea about the pads right here. But this is how it looks. Really nice manual layout. So that was number 1. Now let's have a look at number 2. And what is that? See, this looks like a cat. Also because of how they align the different tracks and all stuff here. So this is a very clearly a cat layout, right? Wouldn't you say that? So that was number 2. Well, I think a lot of the others, they look exactly the same. Yeah, there was actually, I think, yeah, it was this one I wanted to show you. Those are just quite normal stuff. Nothing special or fascinating about this, but hey, look at this one. Look at the tracks here. They didn't even bother to put them straight. They are just as random as you can imagine. I would call this sloppy jobby. Look at that. Clearly manual work, right? But hey, if it works, it works. That is really funny manual layout. And there was one I think is very interesting. This one is number 7. Hey, look at that. I think this is an 8-layer board because, or 6 layers. Yeah, sorry about that. 6. Because you can see straight through, and they added 2 extra layers on top of the normal 4 layers that everything else is made in 4 layers. And look here. They just go directly on top of the other tracks like this. And you can even see layer 3 a little bit deeper as well. So a 6-layer board in 1978. How about that? And this is what happens when you complain to your sponsors about stuff not working. Then you just get a new one, or at least one that works. So now we're gonna test this one instead. So let's test the new unit that was promised to be working. And look at that. Ain't that sweet? And of course I got a 10 dB here. It's about -20, right? And this is -10. Ooh. I really like those variable attenuators. That will be a super good score. Because they're rated for gigahertz, right? So, this thing is actually working. Let's try and play with the, oh, let's see if I can get this. So this says 1000. Oh, look at that. 9, 8, 7. Alright, so as we see, and the next one is 10. Oops, it's of course out. Oh, so that was a problem. 9, and then okay. 1, 2, 3. Okay. Look at that. This kind of jumpy that we see here in between the... This is exactly how the other unit is behaving. Yeah. So there's definitely something with the lock. I'm actually a little bit curious if I can find the bug. But at least I got 2 units. One is working. Now I can just try and swap the modules and see if it's in the modules. That is super easy to do, right? This is actually a little bit funny. I was just starting to unplug modules one by one. Of course, turn off the unit, take one module out, turn it on and see if it still works. And it still works without any of the modules in. And it's still... Look. Oops. This way. 10, 20, 30, 40, right? So still it's doing exactly the same. Frequency stuff is working. So that means my other unit should also work without any of the modules, right? Here's the other one that works. All the different units here, they got numbers. So I mean G24, G6 and 7. Maybe all those numbers refer to sheets in the schematics or the block schematics or something. So so we could much easier figure out what is what. G16 is the output attenuator and G19 here. Yeah, anyway, I'm going to measure a little bit around here and figure out exactly what is what, because now I got a unit that works and it will respond to frequency settings. So now it's easy to sniff around with one of my pickup sniffers. I've been playing a lot with this now because I got a working unit and I got a faulty unit. And now I know exactly why it's doing the funky step dance when it's not working. And that is because this is a mixer and compare unit. This is indeed the VCO. And I believe this little black thing that is hidden inside here is actually the oscillator. So if I set everything for 1 gigahertz output, this one is actually swinging at 100 megahertz, and then every harmonic all the way up to 1 gigahertz in 100 megahertz step. This is what I see on the spectrum analyzer when I look into all this. There's actually a tiny little amplifier chip right under here in the middle of the picture now, and then it goes into a more powerful buffer, and then it goes into a filter and output chamber, and this little resonant circuit you see down here, there's a coil and a tiny little yellow capacitor, and then it goes out. That is filtered for 1 gigahertz. It's actually trying to remove some of the harmonics of that. Then this little black diode and the capacitors here, it's rectifying the output signal, and this is the level handler. So there's also a level system here, so it can do on and off keying and all sorts of digital modes. And all this is the digital mode and level compensation thing, because it measures the output from this. And here we got some feedback system for that. But the 1 gigahertz is now going out, and here is the output of the. By the way, this is the DC. This is the VCO voltage that goes into this oscillator, right? So here is the 100 megahertz, right? And this 100 megahertz goes into this is our little problem child. In here, there's a 91 megahertz crystal, and it is of course here working in this one. Here's my little secret sniffer, so I can see exactly what's going on. And then it's mixed together with this, and yada yada yada. Out comes 10 megahertz that goes into here, and then everybody's happy. And this also delivers the DC voltages to the VCO. This is just a classic VCO feedback system, and I need to find the bug in the other one of those. So we are back to the broken one, and what do you know? I took this sniffer before and was around the crystal here, and bang! I had a lot of 91 megahertz, and it also says 91 megahertz on the crystal. Here's 0, zip, nothing. The fun thing is, I also get 0, zip, nothing out of the other one. So that is actually a little bit interesting. How can they both be done? Or dead? That is weirdo. No! No! This one is working, yeah! Good, good, good. Well, that is not the one we're using right now. Hey! Yeah, see? That is the other one here. This is dead. So this is the oscillator that is not working. Hey. But anyway, now I'm down to this tiny little room that is not working. Ha! I mean, this guy just don't give up. It was so difficult to get this damn crystal out. But anyway, here it is. I think I'm going to try and borrow the other crystal from the other unit that is actually working. That could be kind of cool, right? So here's what I did. I borrowed the crystals from the other unit that I knew was working, put it in here, and now I actually know it's working. And so it goes in a little bit of a search mode, and then after a little while it locks. That is weird, it just worked. Here we go. So this is what happens. I think there is maybe an injection level or something that is a little bit on the low side. So every time I change the frequency, so this is 10 megahertz up. So then it searches, see, this is 10 megahertz up, 10 again, and 10 again, 10 again, 10 down. See, there's a little bit of a search, and the other unit didn't really do it that slow. I think it was a lot faster. And this is because every 100 megahertz there is actually a peak, and so it searches the most powerful peak. So I guess it's not powerful enough to get in locked to this one. So, well, I think we can adjust this if we want to. But anyway, it is working, and so far we can be happy. Yeah, I had to put the analyzer upside down here, or on the side, because I needed a lot of equipment to measure around and figure out how everything worked. So now this unit is assembled and is now working. We're looking at the spectrum actually in zero span mode. So this means I'm actually measuring the power versus time on the RF output. I'm also looking with a scope on the video output. So this is a demodulator on the RF output, so we can see exactly what it is doing. So that means we are now in this transponder test mode. We've got all sorts of different test modes, and we can adjust all sorts of times and stuff. So let's see if I adjust the pulse width control. See, I can measure, or I can change how width it is, the wide, and I can of course change all sorts of distances between the pulses. See, I can move them. Yeah, so this is the width of it, and this is the move or the position, and oh, see, I can even control. So now it goes into a regulation again, and this I can also see. Now I crank down the power. So this is the trigger, and this is the next pulse. I think I can't remember, was it here? Which one? There's one where I can adjust how many I want. I don't know. Yeah, here we go. So this is the time between the pulses. It's now long, and then I go closer, 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 and then I can just oversplat the whole thing. So yeah, it can do a lot of things. It can of course also detect replies and all sorts of stuff. This is only a little bit of what it can do, because honestly I have no clue, to really use this. You can change the display here between all sorts of things. You can change test. Is this the distance? I can't remember. Was it the? I don't know what I did. I had it, count up and do some funny stuff. Acceleration. I don't know how to do this right now. Pulses per second, la 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 la. Then we can do this and that, and I don't know what. Anyway, I think I'm done playing with this, and I will now pack it and ship it back. Here's what I did. I put the defect crystal in the other unit, and now that one is working as perfectly as well. So it has probably something to do with the crystal, or the how well the crystal actually oscillates. But by swapping the crystals, now I got 2 units that's working. However, the digital section of this unit is a lot better. So there was some dodgy stuff in the digital parts in the other one. I just can't be bothered right now to figure this out. But now I got a lot more stuff working. See, I can put in. So this is a double pulse. I can turn it on and off. See that one, and I can control the pulse widths. Yeah, and I can control what kind of more control. Oh, so that is that one, and oh, I got that one too. Yeah, look at that. So I can control how powerful this one is, and that one is individually. How cool is that? And the deviation. Oh yeah, okay. I can move this one, and I can move that one. Yeah, whatever. There's a lot of stuff with the pulses. I can modify and fool around with. So yeah. Not that I know a whole lot about how to use this thing, because I don't have the test or the unit connected that I was supposed to test. I actually got some funny. Yeah, okay, here now it's counting. And is it this one? Okay. Huh. Alright, some stuff is working. Oh, did I forget to say this unit is completely like digital with gates and counters and stuff. There's no CPU in it, and it can do a million complicated things. I think that is really fascinating.